各位好，我们目前现在要进行。各位好，我们目前现在要上的是今天是5月15号，2022年。我们目前要开始上后面我们前面3月3号没有讲完的课程，我们要讲这洗铅。我们先看几段那个soy的那些影片，我们现在来开始播放。
Hello everyone. Today I'm going to tell you about such a metalloid as germanium, which helps to immediately transfer information over thousands of kilometers, creating the modern internet and our future. In the periodic table of chemical elements, germanium is located above tin, in a so-called diagonal region of metalloids, that is, elements which have both properties of metals and properties of non-metals. This element was discovered by German chemist Clemens Winkler, who discovered germanium when studying such a mineral as agrirodite, and he called it after his homeland, Germany. Nowadays, this metalloid is extracted from sulfide ores as a byproduct of zinc production. And, as is usually the case, the Chinese manufacturers control most of the market, producing 80% of all germanium and its compounds. One of the intermediate components in the production of this element is germanium tetrachloride, which is a colorless liquid. If you open such an ampoule with germanium tetrachloride, this chemical will immediately start reacting with moisture from the air, creating fume from hydrochloric acid and germanium dioxide. Nowadays, this chemical is used in the production of germanium of semiconductor quality and also in the production of optical fiber. After reduction, pure germanium looks like antimony or silicon. However, in contrast to other metalloids, germanium is more pale. Its chemical properties are not extraordinary and are very similar to those of silicon. Just as silicon, germanium is a semiconductor, which means it conducts electric current only under certain conditions. There is one experiment which illustrates that. I have put together a simple circuit where the light is connected to the cathode through a crystal made of fine germanium. If we apply current, nothing will happen. The light bulb isn't glowing because of the higher resistance of germanium present in the circuit. However, if we heat up this crystal, the resistance of germanium will be decreasing as the temperature will be increasing, which is why current in the circuit will be getting stronger and the light will be glowing brighter. This happens because, unlike metals, which are good conductors of electricity, semiconductors have what's known as an energy gap, which prevents electrons from moving in the material. The kinetic energy of the electrons increases, which increases the number of electrons capable of overcoming the potential barrier. This property of germanium has been used since the 1950s in making germanium transistors, which boosted the development of semiconductor technologies and electronics. However, as time was passing, the price of these elements kept growing, which is why new technologies were developed. Top time to find silicon, which since the 1970s began to crowd out germanium of the semiconductor market because of its lower price and wider availability. These days, germanium and silicon alloy-based semiconductors are being manufactured more and more, for instance for making solar cells. Besides today, germanium transistors can also be found in guitar effects units. Nevertheless, upon heating up in the air, germanium crystals gradually starts oxidizing, releasing light fume consisting of its oxide and also covering in a thin oxide film. Germanium oxide is a white material, and there seems to be nothing remarkable about it. However, this compound plays a key role in the production of germanium for semiconductors and in the production of high-quality optics with a low dispersion rate. Also, this element has another peculiarity, which is being absolutely transparent. transparent in infrared light, which is why it is used in laser devices, because germanium can reflect visible light, but let red light pass through. Besides reacting with oxygen, germanium also reacts well with alkali. Germanium dissolves quite well in liquid sodium hydroxide, creating such a compound as sodium germanate, which can be used to extract bismuth germanate, which is frequently used in radiation detectors as scintillators, and it is also used in hadron collider particle detectors. However, the most interesting application of germanium compounds must be its use in modern communication technology, namely worldwide transmission of signals. The thing is, more than half of all germanium produced in the world is used for making optical fiber, while germanium tetrachloride is used in the production of optical fiber threads. It deposits on the walls of the glass, being heated, and when mixed with the red hot glass and other mixtures, forms a thin core through which beams of infrared light can pass with minimum distortion, being reflected back of the glass walls based on the principle of tunnel lighting. Adding germanium atoms to such glass decreases light dispersion and increases the refractive index in glass, which significantly improves transmission of signals compared to regular glass. Nowadays, modern optical fiber cost way less than copper wires, which contributes to the development of high-speed data transmission. Just look how many underwater internet cables are laid all over the world. And all of that is possible thanks to such an element as germanium. To sum up, we can say that today germanium is a very important element, which makes it possible for us to immediately exchange data, and properties of this element have made it possible to create a World Wide Web. For the provided germanium for the experiments, I'll thank the company onyxman.com. I'll put a link to their site in the video description.
我们接下来讲习的部分。
Hello everyone. Today I want to tell about such a metal as tin. In the periodic table of chemical elements, tin is the 14th group among the so-called base metals. This metal was known back in the 4th millennium BC. Due to the instability, the price of tin was high. During the Bronze Age, tin was considered to be a strategic metal, as the tin bronze obtained from it is much stronger than pure copper. Tin is obtained from the minerals of cassiterite, i.e. tin dioxide from stannite, that is tin sulfide. In its pure form, tin is a shiny soft metal with a yellowish tinge. Due to the tin oxide covering it, the density of this metal is slightly less than that of lead, the melting point being 232 degrees Celsius. The small temperature of melting tin makes it possible to cast different shapes and figures from it. As an example, the well-known tin soldiers. And plus, tin is not toxic as lead. Also, if you bend an ingot of a very pure tin, you can hear an interesting crunch caused by deformation of crystals inside the metal. The same musical property can also be found in ingots of pure zinc and indium. They could probably start a band together. However, metallic tin, in contrast to other metals, has one unique property called polymorphism. The metal that I am holding in my hand is called beta form of tin, or also white tin. If this piece of tin is then put into a cold place, the temperature of which is below 15 degrees Celsius, then eventually the white tin will begin to shift into its gray form, the so-called alpha form of tin. In this video, courtesy of the website periodictable.ru, you can observe the process of the transition from white tin to gray. Since gray tin has a completely different crystal structure, similar to the structure of a diamond, any product made of white tin with this transformation will simply fall apart into pieces. This effect is also called the tin plague. This is exactly what happened with the many collections of tin soldiers due to the improper storage. Also, some historians point to the tin plague as one of the circumstances of the Napoleon army defeat. Severe frosts led to the transformation of tin buttons on the uniforms of soldiers into powder. From the chemical point of view, tin is a low-activity metal that reacts poorly with dilute acids. But when reacting with aqua regia, tin begins to dissolve actively, oxidizing to tin tetrachloride, which is used, for example, in the production of soap. At temperatures above 115 degrees Celsius, tin begins to gradually oxidize in air, but when it's heated to a temperature of about 1000 degrees Celsius, tin starts burning in air, forming tin dioxide. From the tin compounds, tin chloride 2 is the one most frequently found. We can also carry out a couple of very beautiful experiments with it. I dissolve tin chloride in a 10% sulfuric acid to prevent the hydrolysis of tin chloride in water. Then I pour the solution into a petri dish and attach the electrodes to the edges of the cup. Now, with the help of the adapter, I am passing through the solution a constant current of 1 amperes and a voltage of 6 volts. At the same time begins the process of reduction of tin chloride to beautiful tin crystals as a cathode, and as the anode, tin is oxidized to tin dioxide. Tin crystals look very beautiful, especially in macro photography. By the way, if you change the polarity, the newly formed tin crystals will begin to dissolve and the growth of new crystals will happen from a negatively charged electrode, i.e. the cathode. Such a method of reducing tin under the influence of electricity is used in the production of tinned cans. If you add a piece of zinc to the solution of tin chloride, it will begin to get covered with a beautiful tin crystals. Zinc here will be oxidized to zinc chloride, and tin will be reduced to metal. This results in beautiful tin Hendehoff. At the present times, tin is used mainly as safe, non-toxic, corrosion-resistant coating in pure form, or in alloys with other metals. In ordinary life, we can find tin in the composition of solder. Also, tin here comes as mixture with other metals, mainly with lead. The most important alloy of tin is bronze with copper. Also, tin is an important alloying component in the production of structural alloys of titanium. The tin disulfide is used in the composition of paints imitating gilding. By the way, in recent years, because of the introduction of lead-free solder in electronics, there is now a massive problem. It also called the tin whiskers. That is the formation of long and thin tin crystals grown out of a solder, which in some bores is almost pure tin. These tin whiskers can grow to a decent size, resulting in a short circuit and equipment failure. This effect has already led to a number of failures in electronics, including a complete breakdown of orbiting satellites. The exact cause of this effect has not yet been figured out. However, it can be prevented by the addition of bismuth, antimony, or other low-melting metals to the solder. Now you know a little bit more about one of the other metals. If you would like to support the continuous production of science videos like this one, please support channel on Patreon, link in the video description. Please like this video and subscribe to my channel to see many more new and interesting Today, I'll
这是
tell
讲
you
铅
about
的。
the metal lead. Lead is pretty much at the bottom of group 4 of the periodic table of chemical elements. Of all the non-radioactive elements, this metal has almost the biggest atomic mass. Outwardly, lead is a soft, silvery metal, which is very easy to scratch, since it is 1.5 times softer than gold. It's also very easy to melt metal, because its melting point of 327 degrees Celsius. You can easily create ingots or cast figures from the lead. This metal is very stable on air and does not react with acid solutions, and its compounds are quite toxic, and you need to be careful when working with lead salts. In ancient Rome, lead was often being used as wall facing for the manufacture of pipes and utensils. Romans did not know about the toxicity of lead, which they then subsequently paid for, as lead affects the brain, and then human's psyche then suffers greatly from it. The usage of lead at home is considered one of the causes for the Roman Empire collapse. Let's conduct some nice experiments with lead, or rather with its compounds. In the first experiment, we will take a hot solution of lead nitrate and mix it with a hot solution of potassium iodide, and then we'll wait until the mixture cools down. Upon cooling, beautiful crystals of lead iodide will start to fall from the solution, resembling gold tinsel. We now just did the favorite trick of medieval alchemists, received gold from lead. Also, this is just a chemical delusion. This experiment is also known as the golden rain. Lead iodide crystals look very nice in the dark at lateral illumination. For the second experiment, we will take the lead acetate, which is a salt of lead and acetic acid, and drop a piece of zinc into it. Over time, a layer of lead crystals will start to grow on the zinc due to the reaction of substitution of lead by zinc ions. The layer of lead crystals looks very nice. It turns out to resemble something like a lead handicap. Lead has a very wide application these days. Mainly they tend to make bullets for weapons. Some of those are covered with a copper shell. Lead is also used in the manufacture of lead acid batteries for cars, as a part of solder alloys. Because of its low price and high density, lead is used as a protection against radiation and as a load of fishing floats. Lead is obtained by reacting lead ore concentrate with carbon, after which it is purified from silver, nickel, and other metals. Now you know a bit more about one other metal from the periodic table. If you want to continue this journey of the elements, like and subscribe to my channel to see many more new and interesting. If you would like to support the continuous production of science videos like this one, please support channel on Patreon, link in the video description.
我们先休息一下，好吧？